Welcome back, everyone, for another deep dive. This time we're going to be looking at a really fascinating collection of ideas about sustenance, like from ancient societies all the way to truly mind-bending possibilities for how we might obtain resources in the future.
It is quite the spectrum to work with. I'm looking forward to this.
Yeah, so what we're going to be trying to do in this deep dive is to connect these seemingly disparate points, like the way people survived in the past with the crazy technological potential we might have in the future, and see what kinds of surprising insights emerge from that.
Yeah, that's right. We're really looking at, the ingenuity of those old school hunter-gatherer lifestyles, and then all the way through to the implications of being able to manipulate matter, like at the atomic level. It really is a journey through time, but it's all centered around that fundamental human need. How do we get what we need? How do we thrive?
Exactly. So one thing that really stood out to me when I was going through the material you sent, specifically the stuff from RoboState, Your Majesty asked a question that I thought was really interesting. Is agriculture basically a form of collective hunting and gathering? What do you think about that?
It is a pretty clever way to think about our relationship with food. I mean, when you get down to it, both hunter-gatherer societies and agricultural communities are ultimately trying to do the same thing. They're trying to get a reliable source of food.
Right. But the key difference, I guess, is in how they go about it.
Yeah, exactly. Hunting and gathering, it's a much more direct and immediate kind of engagement with the environment. They're taking what nature provides, just right there in front of them in a very sort of spread out, dispersed way. But agriculture, that's much more centralized. It's a more organized system.
So instead of just taking what they find, they're actually trying to manage and cultivate certain things in one specific area.
Exactly. So you need a completely different kind of planning and a different kind of communal effort to pull that off. So yeah, while both are trying to solve that same problem of, where's the food coming from, the methods they use are like a huge shift in how humans interact with their world to get what they need.
Which, makes me think about another idea that was put up in the material. The concept of a homeless person as an urban hunter-gatherer. I was at first I was like, what? Because, when you think of how much stuff there is in a city, it's kind of a strange comparison.
It does seem counterintuitive at first, but when you start looking at the core survival skills that both groups use, it makes a lot more sense.
I see what you mean.
You've got traditional hunter-gatherers who are constantly adapting to a natural landscape, right? They've got to figure out where to find food, where to find shelter, how to use the resources around them. And in a lot of ways, people experiencing homelessness in a city are doing a very similar thing.
They're scavenging and being resourceful, trying to survive in this concrete jungle.
Exactly. It's all about making do with what's available and adapting to a very, demanding environment.
But the transcript also made it clear that it's not exactly the same. It's not like being in a forest where you have this deep knowledge of all the plants and animals.
No, actually not. It's actually way harder to get resources if you're homeless in a city.
I get it because of things like property laws and stuff.
Yeah, there might be a ton of stuff around, discarded food or clothes or materials, but it's really hard to access it, even dangerous sometimes.
And then you've got all the social and economic barriers on top of that.
Exactly. It's like someone might be surrounded by restaurants, but if they don't have any money, that food might as well not exist. Their access is so limited and unreliable.
It's almost like flipping our usual perspective on its head, right? Because we get to think of the ancient world as this place of scarcity. They had it so much harder than us with food and resources. But in a city, it's kind of the opposite.
It really challenges that assumption, doesn't it? Traditional hunter-gatherer societies, they usually live in these balanced ecosystems, and they've developed this deep knowledge of their environment, passed down through generations.
They know how to forage and hunt in ways that ensure things will keep growing back.
Exactly. It's all about sustainability. But a city, while it might seem like it's overflowing with stuff, it can be a really tough place to find what you need if you don't have money. There's just not that same kind of inherent stability when it comes to getting resources.
And the thing is, hunter-gatherer societies aren't just a thing of the past. The material had some examples of groups that still live this way today, like the San, the Hadza, the Baka.
Absolutely. And recognizing that these groups still exist, and seeing the incredible value of their knowledge about their environments is really important.
Yeah, it's a reminder that there are many different ways for humans to live and thrive.
Exactly. They show us just how adaptable and resilient humans can be. Take the San people of Southern Africa, for instance. They're amazing trackers, and their knowledge of how to find water in the desert is incredible.
Right. And then there was the Hadza in Tanzania. They're known for being incredible hunters and having these really flexible social structures.
Yeah, and you've got the Baka and Baka peoples of Central Africa. Their knowledge of the rainforest is mind-blowing. They know how to use it for hunting, fishing, and gathering. It's something that sustained them for generations. And then there are groups like the Aka in the Congo Basin and the Yethan down in the southern parts of Chile and Argentina. Their ways of life are all about adapting to the ocean, relying on it for survival.
All these groups really highlight how humans can live in close connection with nature in so many different ways.
It's a testament to human diversity and ingenuity.
Sadly, though, a lot of these groups are facing serious challenges today.
That's true. Globalization, the destruction of their lands for things like agriculture and resource extraction, the effects of climate change, even the pressure to give up their traditions for more modern ways of life, it's all putting enormous pressure on these communities and their unique cultures. And it's a real shame because they have so much to teach us about sustainable living and protecting the planet.
And then there are the uncontacted tribes in the Amazon living in almost complete isolation. It's incredible to think about.
It is. The fact that there are still people out there who have chosen to remain completely separate from the rest of the world, it's humbling in a way. It really makes you think about the different paths humanity can take. The material talks about various groups in the Brazilian Amazon, like in the Vale do Javari region. And then there are groups like the Mashco Piro in Peru and the Colina near the border of Brazil and Peru.
They're completely self-sufficient, relying on the rainforest for everything they need.
Exactly. They hunt, gather fish, and they move around. Sometimes they're nomadic, sometimes they're semi-nomadic. But their connection to the forest, it's total. It's unbroken.
And while that isolation might protect them, it also makes them incredibly vulnerable.
Yeah, that's the double-edged sword, right? No contact means no immunity to diseases. And they're at the mercy of things like illegal logging and mining that are encroaching on their land. Governments, like in Brazil, they're trying to protect these groups, but it's hard.
Okay, so we've been talking about how humans get what they need, from the ancient past to right now. But let's switch gears a bit and look towards the future.
Sounds good.
The material you sent brings up a really intriguing question. How could advanced tech, actually be beneficial to hunter-gatherer societies? And I guess the key here is, not replacing their traditions, but enhancing them.
Yeah, it's not about imposing anything new on them.
Right, more like if it makes sense for their communities and they're open to it, then maybe tech could help them address some of the challenges they're facing. Maybe it could even help ensure the survival of their culture and their environment in the long run.
Yeah, exactly. It's about working together, respectfully and collaboratively.
So what do you think of all the tech that was mentioned, from basic mobile phones to those high-tech drones? What do you see as having the most potential for good?
I think even something as simple as satellite phones or two-way radios could be huge for them. It'd mean being able to call for help in emergencies or just being able to communicate more easily within the community.
Yeah, that makes sense.
And then you've got things like GPS and mapping technology could help them navigate their territory more efficiently and find important resources.
I also thought the idea of using drones to monitor the environment was really interesting, like being able to track changes in animal populations or see how healthy the forest is from the air. That kind of information could be really helpful for making sure resources are managed sustainably.
Yeah, and even something like solar power could make a big difference. Imagine having lights and being able to power some basic necessities without having to rely on things that could harm the environment.
Right. And the material also mentioned water purification systems. Seems like that could have a pretty significant impact on their health and well-being.
Absolutely. Clean water is essential.
And there was even talk about foraging and hunting apps.
Yeah, no, that's interesting. What if they could have apps that are developed in partnership with them, apps that incorporate all of their incredible knowledge about plants and animals?
That'd be a really cool way to preserve that knowledge and pass it on to younger generations. Plus, it could help make sure that harvesting is done in a sustainable way.
Exactly. And of course, you've got the potential for lighter, more durable tools made from advanced materials could really come in handy. But the overall point here, it's not about tech taking over. It's about tech being a tool that complements and supports their way of life.
Yeah, used responsibly and respectfully, it could make a real difference.
That's the key. It all comes down to making sure that whatever tech is introduced, it's done with their full consent and participation. It's their culture, their environment, their choice.
Right. Okay, so now let's jump into some more, maybe far out territory. We're going to talk about the future of food. We're going to move beyond the traditional ways of thinking about how we get what we eat. And the first thing on the list is something called 3D printed meat. Have you ever heard of that?
Yeah, it's also sometimes called cellular agriculture. It's pretty fascinating stuff.
So how does it work?
Basically, it's all about growing meat directly from animal cells. In a lab, you completely bypass the need to raise and slaughter animals. And the really cool thing is this cultured meat, it's basically identical to regular meat, chemically speaking, anyway.
Wow. So we're talking about a future where we might not need to raise animals for food anymore.
It's a real possibility.
What are some of the potential benefits of something like that?
I mean, from an ethical standpoint, you're eliminating the suffering of billions of animals. That's huge. And then there's the environmental impact. Think about all the land, water, and energy that goes into traditional livestock farming.
Not to mention the greenhouse gases.
Exactly. So if we could produce meat in a lab, it could potentially have a much smaller environmental footprint. But of course, it's not all sunshine and roses.
There must be some challenges, right?
Definitely. Like one big one is getting the texture and flavor exactly right. We need it to be indistinguishable from regular meat, and we need to be able to do it on a large scale.
Right. If people don't like the way it tastes, they're not going to buy it.
Exactly. And then you have to get regulatory approval, figure out how to make it affordable, and deal with all the cultural and ethical questions that come along with something like this. It's a big shift, and it's going to take time.
And then the discussion takes this really wild turn. It starts talking about putting this lab-grown meat into robots, like robot animals for hunting.
I know, right? It's like, whoa, where did that come from? But it's actually a pretty thought-provoking idea. The idea is to create these super realistic robot animals that act like real prey and have lab-grown meat inside them.
So instead of killing a real animal, you'd be hunting a robot.
Exactly. And it wouldn't just be for humans either. The material suggests that wild predators could hunt these robots too.
It's like you get to experience the thrill of the hunt without actually harming any living creatures.
Exactly. And the material outlines a bunch of potential benefits, like it could help conserve wild populations.
Because predators wouldn't be hunting real animals as much.
Right. Plus, it could be a really cool way to study animal behavior. Like, imagine being able to observe how predators interact with these robotic prey in a controlled environment. And for humans, it could be a form of hunting that aligns with ethical concerns about animal welfare. But, it's not without its challenges.
Like what?
Well, first of all, you'd have to make these robots look and act like the real deal.
They have to fool the animals, basically.
Yeah, which is really hard to do. And then you'd have to make sure that the interactions between real animals and these robots is safe.
You wouldn't want the robots to hurt the animals or anything.
Exactly. And then there's the whole issue of whether people would even be okay with this kind of thing. Like, would it be accepted culturally?
Right. It's a really radical concept.
Yeah. And of course, you'd need some pretty advanced tech to make it all work.
And then it gets even crazier. It talks about these robots transforming when they're captured.
I know, right? It's like, what?
Like a robot monkey turns into fruit when a chimp catches it, or a robot gazelle releases some kind of meat-like substance when a lion takes it down. It's crazy.
It's like straight out of a sci-fi movie. But the idea at its core is that you're encouraging these animals to engage in their natural behaviors, but you're doing it in a way that's controlled and maybe even beneficial. Like it could help with conservation efforts. Maybe you could even tailor the nutritional content of what the robots release.
But like, how do you even begin to create something like that? I mean, you need robots that are so advanced they can fool these animals completely.
That's one of the big hurdles, yeah. It's a massive technological challenge. And then you have to think about the potential unintended consequences. Like, could messing with the food chain like this end up harming the animals or the ecosystem in some way? And then, of course, there are the ethical questions. It's kind of like playing God with nature in a way.
It makes you wonder, how far is too far when it comes to tech and nature?
It's a really important question to think about as we move forward.
All right, well, let's keep exploring those boundaries. The next part of this deep dive takes us into the nanotechnological realm.
Nanotech. Now we're getting really tiny.
Tiny is right. We're talking about building things atom by atom. Atomic level additive manufacturing. I mean, for someone who might not be super familiar with all this, can you break that down a bit?
Sure. Basically, instead of working with big chunks of material and shaping them, we're talking about manipulating individual atoms, putting them together like tiny building blocks to create new structures. Techniques like scanning tunneling microscopy and atomic force microscopy, they allow us to see and even move these individual atoms. It's like having the ultimate level of precision and control over how you build things.
So you can create materials and structures with properties that we've never seen before.
Exactly. And this could have huge implications for everything from electronics to medicine to energy production. Think about it. Imagine building electronic devices that are way more powerful and efficient because their components are engineered at the atomic level.
Right.
Or in medicine, we could create drug delivery systems that target specific cells with incredible accuracy. And in energy, we could develop entirely new materials for solar cells or catalysts for chemical reactions. And advancements in areas like DNA origami, where you actually use DNA molecules as building blocks, that's really showing us the potential of this kind of controlled construction.
But it sounds like we're still a ways off from seeing this kind of tech in our everyday lives, right?
Yeah, it's still early days.
What are some of the big challenges that are preventing this from happening?
Well, one is just scaling things up. Like going from doing this in a lab to being able to mass produce it is a huge challenge.
Yeah, I imagine.
And then there's the issue of precision and control. We need to be able to do this really precisely every single time, and it has to be cost effective.
Right.
Plus, we're still learning about how atoms interact at that level.
Yeah, we've got a lot more to discover before we can truly master this kind of technology.
Exactly. But the long-term potential, especially if we can figure out how to combine this with artificial intelligence and machine learning, it's massive.
I mean, could you imagine AI designing and building these structures?
That's the dream.
Yeah. Okay, and then the discussion goes even further, suggesting the possibility of self-replicating nanoscopic 3D printers.
Yeah, now we're talking sci-fi level stuff.
Seriously, these are like tiny robots that can make copies of themselves using nothing but water and sunlight.
It's definitely pushing the limits of what we currently think is possible, but it's a really cool thought experiment. Think about it. Sunlight could provide the energy through advanced solar tech.
Right.
And water, which is made of hydrogen and oxygen atoms, that could be the source of the building blocks.
The raw materials.
Exactly. But the real key here is the idea of self-replication, where these nanobots can build copies of themselves using the resources around them, just like how cells in our bodies reproduce.
That's molecular manufacturing, right?
Precisely. But the challenges are immense. I mean, can you imagine trying to design and control machines that small that can do all of that?
Yeah, it seems almost impossible.
It would be unbelievably complex. Like they'd have to be able to harvest energy, extract resources, and then assemble all those atoms into perfect copies of themselves.
And all of that at a size that's almost incomprehensible.
Exactly. And we also have limitations with materials. Like what could you even build these things out of?
Right. They would have to be durable enough to survive in whatever environment they're in.
Absolutely. And energy efficiency is critical, especially for self-replication.
And let's not forget the whole gray goo scenario. That idea of these things replicating out of control and consuming everything in their path. That's scary.
Definitely a valid concern. We'd have to figure out some pretty serious safeguards.
But if we can actually pull this off, the benefits for humanity could be pretty incredible.
Oh, yeah. I mean, imagine a world where we could manufacture anything we need on demand using just sunlight and water.
And with minimal waste.
It would be a revolution in sustainable manufacturing. We could create new materials with all sorts of amazing properties. Plus, the knowledge we could gain from understanding how to create these self-replicating systems that could transform fields like synthetic biology. It's pretty mind-blowing when you think about it.
Okay, now on to part 5. This one really blew my mind. It's about the idea of, get this, nuclear alchemy at the nanoscale.
Ah, yes. Turning hydrogen into diamonds with tiny robots in the ocean.
You make it sound so casual.
Well, it is pretty wild stuff, but the material starts by explaining how carbon, the element that makes up diamonds, is formed in stars through nuclear fusion, right?
Right.
Lighter elements like hydrogen get smashed together to form heavier elements like helium, and then through a process called the triple alpha process, helium fuses into carbon. This takes an immense amount of energy and crazy high temperatures.
And they say that it takes 12 hydrogen atoms to create one carbon atom. That's pretty wild in itself.
It is. So the question then becomes, could we somehow copy these nuclear reactions but do it at a really, really tiny scale?
Yeah, could we make diamonds using nanotech?
Well, the biggest hurdle is that to trigger fusion, you need a crazy amount of energy. We're talking temperatures of millions of degrees.
So just shrinking the size of the machine doesn't solve that problem.
Exactly. It's not like the laws of physics change just because we're working at a smaller scale. In fact, containing and controlling that much energy in a tiny space, that would be way harder than what we're trying to do with large-scale fusion experiments right now.
And the material also mentioned that the materials we have right now, they couldn't handle that kind of heat and pressure.
Yeah, there's no known material that could withstand those conditions at the nanoscale.
So it's like a double whammy.
Exactly. And we're still figuring out how to do controlled fusion on a large scale, like with methods like inertial confinement and magnetic confinement. We're a long way off from being able to apply those principles or even come up with completely new ones that could work at the nanoscale.
But that doesn't stop them from imagining it, right? The material goes on to describe these self-sustaining, self-replicating nanobots in the ocean. They could turn water into diamonds through this hypophysical nanoscale fusion.
Yeah, it's a pretty audacious concept. I mean, you're talking about nanobots that would have to be incredibly durable to function in seawater. Then they'd have to extract hydrogen from the water, which takes energy. Then they'd have to trigger and control nuclear fusion to turn that hydrogen into carbon. And they'd have to assemble those carbon atoms into a diamond structure, and all of this while making copies of themselves.
And somehow dealing with all the potential environmental impacts.
Right, like what happens to all the oxygen they release? What about changes in water temperature?
So it's safe to say that this is still firmly in the realm of science fiction.
For now, definitely. The two biggest hurdles, controlled diffusion at that scale and making machines that complex self-replicate, those are massive. But hey, it's fun to imagine the possibilities.
Okay, let's come back down to earth a bit. The next part focuses on information density, like taking all the knowledge that humanity has accumulated and figuring out how to store it in a super efficient way.
Now that's a topic that's close to my heart. Information, the building blocks of knowledge. It's fascinating to think about.
The material starts by giving some estimates of just how much information we're talking about.
Yeah, and it's mind-boggling. We're talking zettabytes, maybe even yottabytes of data.
I don't even know what those numbers mean.
A zettabyte is like 1 trillion gigabytes.
Wow.
Think of it like all the data that flows through the internet in a whole year. And a yottabyte, that's 1,000 times bigger.
Okay, so we're talking about a truly massive amount of information. And the material then introduces this idea of using diamonds to store all of that.
The data diamond concept. The idea is to use carbon isotopes within the diamond, specifically carbon-12 and carbon-13, to represent ones and zeros, the basic building blocks of digital data. And because you're literally using individual atoms to store information, the storage density is insane.
Like how much data could you fit into a diamond?
Well, calculation suggests that you could potentially store petabytes of data in a single cubic centimeter of diamond. That's way more than anything we have right now.
Wow.
The material even says that you could theoretically fit all of human knowledge, everything we've ever recorded, into a diamond the size of a grapefruit.
That's incredible. So does this mean we could all have tiny diamond hard drives in the future?
Well, not quite yet. The research on isotopically pure diamonds, it's more focused on their material properties, We're not quite at the point where we can precisely control those isotopes at the atomic level to actually store and retrieve data reliably.
Right, so it's more of a long-term possibility.
Yeah, it's going to take some major advancements in nanofabrication and quantum sensing before this becomes a reality.
Okay, so we can't store all of human knowledge in a diamond just yet. But the discussion then moves on to the potential size of a future artificial general superintelligence, or AGSI.
Ah, yes. Trying to predict how complex a true AGSI would be, that's really speculative.
Right.
But the material suggests it might require storage in the exabyte range.
That's 1,000 petabytes, right?
You got it. And if we could actually achieve atomic level storage in diamond, the space you'd need to store an AGSI, it becomes incredibly small.
How small are we talking?
Like a grain of sand, maybe even smaller.
That's insane. So you could have all the knowledge and intelligence of an AGSI packed into something you can barely see. And then, of course, the material takes it one step further, talking about putting this diamond storage into a self-replicating nanobot.
Ah, yes. The ultimate merger of knowledge, intelligence, and nanotechnology.
Creating this kind of decentralized, planetary-scale neural network.
Imagine countless microscopic robots, each one carrying the entirety of human knowledge and powered by advanced AI. They could operate independently, learn, adapt, and even make copies of themselves. It's like this exponential explosion of intelligence spreading across the globe, maybe even beyond.
The material raises a really interesting question about this, though. Would this swarm intelligence operate with, like, a shared goal? Or would each nanobot have its own agenda?
That's a crucial question. Like, would there be some kind of overarching purpose guiding their actions, or would they be more like individual agents, making their own decisions based on what they encounter?
Yeah, that really makes you think about what intelligence and consciousness might look like in the future.
It does, and it raises some profound ethical considerations as well. Like, what happens if we create a form of intelligence that we can't fully understand or control?
That's some serious food for thought.
It is.
Okay, for the last part of this deep dive, we're going to look at a really interesting concept that came directly from one of our listeners.
Oh, this should be good.
It's about gamifying the future, like tying together how we get food and how we stay healthy. It's a world where AI robots hunt, and the meat is bought using a special cryptocurrency that you earn through physical activity.
Fit points, I believe they were called.
Right, like proof of work through exercise.
It's an intriguing concept, and it tries to solve some pretty big problems that we might face in a highly automated future. Like what happens if machines take over all the jobs? What happens to people who can't work or don't want to work? And how do we stop the rich from just hoarding all the wealth?
Yeah, and how do we make sure people stay active and healthy when everything is done by robots?
And on top of all that, how do we do all this while protecting the environment? So the listeners who sent this in, they've come up with this system where everyone has to earn their food and their health care through exercise. And it all revolves around hunting robot animals with the help of AI.
The material lists out a bunch of benefits, like no more need for traditional agriculture, which would free up so much land and resources. And it could prevent people from being, basically useless in a society where robots do everything.
It's about keeping humans in the loop, giving them a purpose, and keeping them healthy.
Yeah, it's like a built-in incentive to stay active. But of course, there are a lot of practical challenges too, right? Like, how do you create enough robot animals, whether they're real or synthetic, to feed everyone? How do you measure how much exercise people are actually doing? And how do you make sure that AI doesn't end up controlling everything?
That's a lot to figure out.
The listener really went all in on the gamification part, though. It's like a whole new way of living. You'd have missions to get different kinds of food, an AI-controlled market where the price of meat fluctuates based on demand, and maybe even augmented reality to make the hunts more exciting.
It's like turning everyday life into a video game.
Yeah, and the concept even extends to healthcare, where the fit points you earn could be used to pay for medical expenses.
It's like a built-in health savings account. The healthier you are, the more you earn, and the better you can take care of yourself. And they even suggest that AI could create personalized fitness missions based on your individual needs and goals.
That's pretty cool.
It is, but it all circles back to that fundamental question we talked about earlier. Would these robot animals be synthetic, or would they be real, living creatures?
Yeah, that's a big one.
On one hand, synthetic animals would give you more control. You could design them with specific nutritional profiles and avoid the ethical concerns of harming living beings. But real animals, they connect us back to nature. It's a more authentic experience, but it comes with a whole set of challenges, like how do you make sure it's sustainable? How do you manage the populations? And what about the ethics of hunting?
It's definitely a complex decision with no easy answers.
It really is, but it's a discussion that's worth having as we think about the future of our relationship with food, technology, and the natural world.
Well, I think it's safe to say that this deep dive has covered some truly mind-blowing stuff.
We've gone from the basics of human survival, how our ancestors figured out how to find food, to some of the most advanced and even fantastical technological possibilities that we can imagine.
And it's amazing how interconnected